Hello guys and welcome back. Today will be our next day for the JEE Advanced 100-day question series. And guys, I am receiving a lot of requests on chapter related, like bring this chapter, bring that chapter. So guys, I am like, see, these videos are like pre-recorded, so maybe processing your requests for me at that very moment or for the next question might be a bit difficult, but don't worry, I will bring things, okay? And I will try to bring more of the combinatorics Olympiad problems also. Although they are not very relevant, like that level is not going to come in JEE, but still I will try, okay? Like they are very difficult questions, okay? And for that question that I brought last time, I had received about 15-20 messages of people texting me like this question is really difficult, I can't understand and all, okay? Anyways, so guys, today's question is again from the book Math Storm Olympiad Problems. And also a small disclaimer, like last video which I put from this book itself, many people were telling that the questions are irrelevant in this book. So guys, a clear thing is I have already told you in the last video, but still I will repeat it once again before starting. See, this book is meant for IMO people, okay? The people who are preparing for IMO Olympiads and etc. This book is actually meant for them, but because it contains a little bit of calculus questions, so I will bring only those which I find are particular to your syllabus, okay? Don't go beyond that, because proof, induction, these things are not in your syllabus. Just do whatever I am giving you, okay? That's it. Like if you are preparing for Olympiads, then obviously go forward, but otherwise don't touch this book, the questions. Whatever I am giving you, I am doing here, just do that, okay? So guys, I hope we can proceed. The question is right now on the screen. If you want, you can try the question out. I will wait for a few seconds and then start off solving. Okay guys, so like let's start off. So basically the first part of the question is really easy, because f of x plus y is equal to your, I will write it down maybe once, f of x plus y is equal to f of x into f of y, right? So this thing is actually possible for only one case. We obviously know that from functional equations. This is for f of x equal to c into a power x, okay? So we need to find c and a obviously. So if we like see the conditions, first condition is f of 0 is equal to 1. So f of 0 means this will become ca is equal to 1. First thing, and second thing is f dash 0 is equal to minus ln 9. So if we find out f dash x, this is very simply c a power x ln a, and this thing is equal to given as minus ln 9. Okay, and also this is f dash 0. Okay, I will change the screen, wait. Yeah, so f dash 0 is given. That means this thing will actually become, okay, a power, okay, wait, a power 0 is actually 1, so this is not ca, I'm sorry, only c equals to 1, okay? So actually you don't need c anymore. And here f dash 0, so ln a is equal to minus ln 9, so very simply a becomes minus 9. So guys, this will be f of x equal to 9 power minus x, okay? So this is not like very difficult. The first part is really easy to find, but the secret of this question is not in the first part, it's in the next part, because I found it to be really interesting, okay? Like this can be considered as a medium level JEE Advanced question. Sort of it includes integration and little bit of series you will also see in the last, okay? Series and progression flavor also. I will show you. Okay, so guys, our function is found, but right now if you actually notice this thing, sigma, its limit n tends to infinity sum, okay? So I guess this will maybe, we can write it in terms of sigma. So let's do that, I guess that will be better. So right now, your sigma, like if you observe the pattern anyways, our final term is given as 2n plus 1, so this will be limit n tends to infinity. And sorry, this is not sigma actually, this is ohm, okay? Everywhere ohm is used, I don't know why these people are so obsessed with electricity. Anyways. So this is your limit n tends to infinity, and this will be sigma r equals to 0 to n 2r plus 1. Okay, and this thing is root under of integral x to infinity. Yeah, and this thing is f of x plus r and whole root under dx, I guess. Yes. This is your expression in a compacted form, and this was also squared up. Okay. So right now, I guess first thing that we can very easily do is integrate this part because f of x is already ready with us. So this will simply be sigma r equals to 0 to n to r plus 1, and this will be root under of integral x to infinity. This thing is 9 power minus x plus r dx. Okay. So evaluating this will be very simple. I am jumping one small step here. Okay. One small step, like just the evaluation of this part, and I will write the answer directly for you guys. This will actually come out to be sigma r equals to 0 to n to r plus 1, and this thing will be multiplied by 3 power minus x plus r. I hope you can understand why, because this thing is a whole squared thing, right? So when it comes out of the root, it will actually, like, I'm sorry, whole square is outside the bracket, but this thing, when it comes out of the root, 3 power minus 2 into x plus r, so 3 power minus x plus r, and this thing is whole divided by ln 9, right? I hope you can understand where ln 9 will come from. Anyways, just evaluate that, it will be pretty easy. I just jumped one small step. Okay, so right now we can write this as your 1 by ln 9 limit n tends to infinity, and this will be sigma r equals 0 to n to r plus 1 into 3 power minus x plus r. Okay, so guys, this is the like sort of value we have to find, and if I want to evaluate this a little bit, manipulate, because 3 power minus x, I don't think it has anything to do with this thing. So okay, there's a square also here, so what we can do is we can take it out. So 9 power minus x by ln 9, and this thing will actually become your limit n is tending to infinity, and your final expression is sigma r equals to 0 to n 2r plus 1 by 3 power r whole squared. Okay, I guess this will be your expression. Okay, so guys, to find this thing out, actually what we have to do is we have to apply our series and progressions. Okay, so let's do that. So guys, right now what I am going to do is I will expand this particular term in a general form s. Okay, so if you expand, it will be, I guess, pretty easily 1 plus, the first term is coming to be 3 by 3 power 1 plus 5 by 3 square, and this will be, I guess, 7 by 3 cube, and obviously up till infinity. So if I, like, very classic method to do this, I hope all of you know, is dividing s by 3, because then we can subtract. So this thing becomes 1 by 3 power 1 plus 3 by 3 square plus 5 by 3 cube. I hope you all, like, all of you know this classical method, right? This is a lot like asked in your JEE mains and stuff, but also important for advanced. Anyways, so if we subtract these two expressions, this will become 2s by 3, and this thing becomes 1 plus, this will actually become, like, the difference of all these terms with the same denominator obviously would come out to be 2. So I'm taking 2 common out, and this thing will become 1 by 3 plus 1 by 3 square up till infinity. Obviously a GP with common ratio of 1 by 3. So this becomes 1 plus 2 into, and this is 2 by 3, I guess. Yeah. So 2 by 3, and like if we take a 1 by 3 common out from here, or you can also include the 1 by 3 and do it. Anyways, it's an infinite GP sum. So if I take 1 by 3 outside common, then this will be 1 by 1 minus 1 by 3. A by 1 minus R. So this thing becomes sort of 1 plus, I guess, 3 by 2 into 2 by 3. So 1 plus 1, 2. That means your S is equal to, I guess this will become 3 only. Okay. So infinite sum GP, it becomes equal to 3. So I guess sigma will become equal to 9 power minus x divided by ln 9, and this will, I guess, be equal to 3. Okay, not 3, 3 squared. So actually I can write this as, final if I want to write, I can write this as 9 power 1 minus x, and if you want to bring the log term to the numerator to make it look good, you can write this as log e base 9. So this will be the final answer for this question. Okay. Anyways, like, we did a little bit easy question today because, like, see, honestly, if I tell you, I'm really running out of very good questions. Okay. So it takes a lot of time actually to find out the good ones because, like, obviously Vishal Tiwari sir's questions are there, but if I leave it also, there are a lot of good questions which I have to find. Okay. So that takes a lot of time. So maybe this is not a really low level question, but sometimes the level of questions might go up and down. Okay, little bit. Anyways, guys, this will be the end for today's video, and I hope you have liked this. And also, the question was not very interesting, but the last part is something that might work. Okay. Anyways, guys, that's the end for this video. If you have liked my channel, do like, share, and subscribe. Any doubts, anything, do come out in the comment section, and also do join my Telegram discussion chat because I'm uploading a lot of things there. Okay, and this is the end for this video, guys. I hope I will make the next video that will come a bit more interesting with a difficult question. Anyways, that's it for today. Let's end this video here. Thanks for watching.